We're live, man.
We are live. We are so live.
How's everyone doing tonight? Very first time where we're running a 101. My name is John Kuchmek. I'm actually the host tonight. I didn't get to do any of the work, thank God. Carolyn did all the work. All I have to do is talk. But I actually run the Future of Data in Philadelphia. UPenn represent. Of course, the East Coast is the right coast, right? Of course, the left coast is the wrong coast. That's not my fault. But
sorry for those of us, West Coasters.
for those of you who are who are with us from all over the world, appreciate it. I want to introduce you to Carolyn. Carolyn, take it away.
Hey, how's everybody doing? All right, we are ready to start our new meetup series. So a lot of our meetups, I run the Future of Data, Providence, and Boston meetups. John runs his meetups, and we got Tim Span, who also runs meetups down in the New Jersey area. So everything's virtual now, and I've been hearing from a lot of folks from the meetups about, they're like, wow, these things that you guys are doing about, you stand on your head and you stream some data and then you run like 15 machine learning algorithms and then, magic occurs. And people are like, well, that's great, but I don't even know how to get started with this stuff. This stuff is like way too advanced. So it is January. And, January is the time for New Year's resolutions. I'm sorry for the New Year's resolutions haters. But if you want to, January is a great time to learn stuff that's new in the Northeast. The weather's terrible. There's COVID and there's nothing else to do, basically. So let's learn Hive. This is a 101 Hive presentation. If you're an expert in Hive, you probably are going to find this too basic. But we're going to really boil it down. This is a hello world in Hive to kind of give you enough to get started. And then we'll give you some resources to kind of take the next step. So is the theory.
Real quick, though, before we get started, right, we are streaming on LinkedIn. We are streaming on YouTube. We are streaming on Twitter. So one of the things that I want to let you guys know is that as we're going through, we actually have people in the back that are monitoring all of the questions. They're going to put the questions in together. If it's a question we can quickly answer, I might interrupt Carolyn like I just did right now and say, hey, Carolyn, we have a quick question. Maybe it's something, we can get to. If not, we're definitely going to have some Q&A at the end. We'll have all of the questions. So we'll be able to say what platform the question came from, who the question came from. But definitely you want to get those questions in. Now, Carolyn, you talk about, doing new things come January. I think this is a brilliant idea, right? So how did you come up with this idea?
It was really just feedback from the members of the meetup. We have quite a few members in the Boston and Providence area. And, a couple of people were like, I really need something basic. This stuff is too advanced for me. I want to learn how to do something. We're really trying to reach out to developers and to help them get started. This is a great thing to do to advance your career, to learn something new, to, improve your resume, and just overall stimulate your brain with some big data. So that's the theory. So John, you're gonna tell us about the prizes. There are prizes.
We are. And I'm gonna give you a little more than just the prizes. So if you take a look, right, and Chewy, why don't you let me share my screen right here. Let me pop it up, screen 4. There you go. So if you look here, right, obviously Carolyn did all the work. This is even her deck. But our marketing team, so Carolyn and I both work for Cloudera. Our marketing team did an awesome job. So we definitely want to thank them before we start. Tui, Bill, everyone behind the scenes, we really appreciate it. But there's some serious swag that I don't even have. So you look at first place, right? The sweatshirts, I've seen them. That bag is definitely something I want. Just take note, Bill. And then second place, even the T-shirts are great. So how do you get a prize? That's the question. Well, we're going to actually do a raffle at the end of the meetup. So you have to stay for the whole thing. If you're not here when we call your name, you don't get a prize. The other thing that you have to do is you have to participate. How do you participate? Very easy. Ask questions. So type away if you're in LinkedIn, type away if you're on Twitter, type away if you're on YouTube. Ask those questions, and like I said, we'll get them in. You got to participate in order to get those prizes. But if you do, I mean, that's some serious. If you go to the Cloudera store, you're talking about over $100 right here easily, right, for that first place prize. And the agenda is going to kind of go like this. This is an overview, and I say we bring Carolyn back on, right, because at the end I'm going to end up doing the questions. So let me stop sharing momentarily, bring Carolyn back on. But we actually we're going to have, what is Hive, why use Hive, how to use Hive, and anything more to learn. So I don't want to keep you away from other content, Carolyn. I think it's time for you to take the stage and for me to shut up.
All right, thanks, John. So as John said, we are streaming live and anything can happen. I have cats and they do occasionally make an appearance. They are cats who insist on helping with all tasks in the office. So if you see a cat, don't be alarmed. Okay, so let's get started with some sharing here. Let's see if I can remember how to share. This is very sad. Let's try that again. There we go. Okay. Like I said, anything can happen. Okay, here we go. All right, hello, Hive. We already talked about the prizes. You have to be here to win, but you're going to want to be here because you want to learn everything that you possibly can about this. Okay, so what is Hive? Well, first of all, who am I? So I am Carolyn Duby. I am a principal solutions engineer. John and I are peers at Cloudera. We help our customers with technical questions, reference architectures. It's an awesome job. I'll have to say, this is my best job ever. And I've had some really good jobs. So anyways, my specialty is high performance data pipelines, cybersecurity, streaming, data science. But I'm kind of going a little bit outside of my core area of expertise to talk about Hive and data warehousing, because as you know, cybersecurity involves a lot of data and it streams into the system, but then you have to land it somewhere and then you have to query it and you have to find analytics. You have to be able to do analytics. You have to be able to do interesting things with it. So data warehousing is also, once you land the data, it's also a big part of cybersecurity as well. So I would love it if you would give me some feedback on this presentation, anything you want to learn more about. If you have other Hello series meetups that you're interested in, we're very interactive here. John and I love hearing from you guys. So give us a shout out. Let us know what you think. I am also easy to connect with on Twitter at Carolyn Duby or at LinkedIn. LinkedIn and then my name. So LinkedIn, follow me on Twitter. Anyways, so what is Hive? So Hive is an Apache open source project. Apache open source is basically a project. There are literally like hundreds of Apache open source projects. They are collaborations from different contributors from different companies, individual contributors, people all across the world. And they are, they have to reach a level of being a contributor to an open source project. So there's a few hoops to jump through there to get in. You have to be, a pretty decent developer. Maybe work for a company that has these open source that supports these open source projects, or just be a really good person in the community that donates your time. So it's open source project. It's governed by the Apache project, the Apache Foundation's processes, and it goes through all of the governance of project. So there are lots of open source projects, and Cloudera is one company that supports Apache open source. There are many, many companies across the world that support different projects. So Apache Hive is a data warehousing open source project. It is all about having access to petabytes worth of data. So not just any access, but access using SQL. And SQL is kind of the standard language of being able to query data. So, if you look at anything like MySQL or SQL Server or any of these products, they have a language that you can use to access the data. Well, Hive is SQL access on lots and lots of data. It's horizontally scalable, so it means you can add more nodes, and some of these clusters that support Hive get really, really large, depending on the size of the data. The data warehouse can be either on premise in your data center, or it can be in the cloud. So Hive was originally created by Facebook, and the reason that they created it was they had lots and lots of data. This was even like 10 years ago. 10 years ago, Facebook had a lot of data, and now they have tons of data. So they needed back in the old days, there was only MapReduce jobs to access data and to do analytics on it. And what that involves is basically writing Java programs and understanding, how to do MapReduce and how to structure these kinds of jobs. It was a pretty technical experience. And the people at Facebook were like, hey, I just want to get an answer to my question. I just want to query it with some SQL. And so they came up with Hive, which is a big data SQL platform. And they used it for many, many petabytes of data. It's a very actively developed project in the Apache program. It has multiple contributors, and it has pretty wide industry adoption. So it's a really good thing to learn. Pretty much everybody that's using big data uses some Hive in some respect. Okay, so why are we using Hive? Well, we already talked about the fact that we had a lot of data. So Hive is technically an online analytical processing tool, or OLAP. And this means basically, it's just a fancy way of saying, I need to be able to query and do reports and do BI dashboards on top of data. It's really good for joining multiple data silos. So a lot of times enterprises will go and they will have lots of different pockets of data. And these pockets will be pretty specific to a specific aspect of the business. So a lot of times it's hard to get a really comprehensive view of something like a customer. If you're in the healthcare, patients. If you're in, delivering things, logistics, right? So it gets down to, for example, I was working with a retail customer, and the retail customer was like, hey, we don't really know. We ordered something, and we have an order management system, but we don't really know, did we ever get it? Because that goes into the warehouse system. So they wanted to be able to bring everything together in a 360 for their logistics. And then also for customers, we know, okay, here's the tickets that the customer put in, when they were interacting with customer service. Here's the orders that they've made. Here are the clicks that they made on the website. Can we see that all together? The other reason to use Hive is to store a longer context of data. So a lot of times there might be a relational database system that can only hold so much data, so the data ages off after a while, and you want to be able to, maybe it stores like 30 days. You want to be able to store years and years worth of data. So you capture that off of the relational database, and you stick it into something like Hive so that you will have a longer context. And also, if you have a data set that is just too large, so there are certain types of data that get very, very large, and companies just can't collect and store them because they don't have the big data technology. And so they're losing that data and the insights that you could get from that data. So, everything when you start looking at tools, like if you're going to build something and you need to hit something with a hammer, you can either use a sledgehammer or you can use a regular hammer. So sometimes you need the sledgehammer and sometimes you just need the regular hammer. So when you have a small data set, don't get out the sledgehammer. Use something simpler like a relational database system, or just use something that's better for smaller data sets. If you are doing something like OLTP, which is a fancy way of saying something that is transactional, it's coming through, it has to be real time, it has to be really fast, it's streaming, that's when you're going to use something like HBase, or we call it the operational database. So if you look at a lot of like trading systems, financial transactions, online bookings, those are all done on top of an online transactional processing system. The other case where you probably don't want to use Hive is if you have like thousands and thousands of users and they really need to query different types of data and they really need fast access to it. That is not a great strength of Hive. It's really good for supporting, those more sorts of BI and reporting technologies. It can go fast, though. Okay, so let's get down to it here. How do we use Hive? So the first thing you have to do is you have to have some Hive, right? So you can deploy Hive either from open source, or you can use a distribution like Cloudera's data warehouse or Cloudera private cloud base. Sometimes getting up and running with a Hive instance is kind of hard from the open source because you have to follow directions, you have to do Maven, you have to do a bunch of things, you have to build the binary. So using it from a distribution like the Cloudera distribution, or there are other distributions that include Hive, is a really good choice. The database, so there are different ways that you can interact with Hive. So one thing you can use is you can use a database UI, something like Hue, which is short for the Hadoop user interface, which basically will give you like a GUI. I also have the Data Analytics Studio, which I'll show you when we get to the demo. And you can use a beeline command line. There are lots of different JDBC tools you can use. You can also use visualization tools such as like Tableau or Cloudera DataViz, where you can take and build visualizations on top of the data. And you can also use Spark applications and then run those Spark applications in a notebook like a Jupyter notebook or a Zeppelin notebook. So really, there are lots of different ways that you can use Hive, but all of them kind of form around this basic capability and this basic knowledge. So let's go. So I'm going to start at the very beginning. We're going to talk about basically how are these databases organized. So you have a Hive data warehouse, and that data warehouse is divided up into a number of pieces, and each one of those pieces is called a database. So you can think about databases as being a logical package of data, and the reason to separate them is so that you kind of have the tables organized. If I want to, for example, if I'm looking at an airline data warehouse, I might have a database that is flights. Here's all the flights, the schedules, the passengers, that sort of thing. And then I might have a separate database, which is aircraft maintenance. So it's really just a logical organization. There's no right or wrong way to do it. You could potentially have just one big database and put everything in it, but then it might be kind of hard to find what you're looking for. Inside the database are a set of tables, and the tables are storing the data. So each one of the tables has rows and columns. For example, in the flight database, we might have a flight table. We might have an airport table. In the aircraft maintenance database, we're going to have the aircraft table and the maintenance table. And those are going to be storing all of the data that's relevant to flights or aircraft or airports. So the first thing we have to do is we have to create a database. So it's very simple. We've got our UI, database UI, or some other way to interface with the database. We're going to do create database flight. So you're just going to say create database and then give it the database name. And then if you want to see what databases are there, you can do a show databases. And so you can see on the right-hand side, on the left-hand side, we created the database flight, and then we're showing the databases, and we can see here it is right here, our flight database. Now, if we think about a table has rows and columns, and it's really intuitive, I think. Here's a table that I kind of copied out of, I copied this off of a flight site that tracks flights. And I thought it looked like a really nice representation of flights. And it kind of gives you an idea of what a table might be. So each row is an information about a flight, and each column is a different piece of data that's associated with that flight. So we've got the airline, the identifier for the flight, the aircraft that it's on, what time did it depart, what time did it arrive, etc. So let's create a table. So the first thing we have to do is we have to tell Hive which database to use. So we say use, and then we say the database flight. And then we're going to say create table. So we create table, and then we're going to give it the name. So we have the flight schedule is the table name. And then we're going to give it all of the columns in the table. And so the columns are defined by a name and the type of the data that's stored in that column. And this is called the table schema. So for this flight schedule table, we're going to have an airline, which is going to be a string, a flight ID, which is also going to be a string. We have a couple of other strings in here, the aircraft model. We're going to have the scheduled departure time, which is going to be actually a timestamp. So a timestamp consists of both a date and then a time. And then we're also going to have a departure airport code, scheduled arrival time, arrival airport code, and estimated flight time in minutes. And I put that there just because I wanted to show you what an integer looked like. But there are lots of different types of columns that you can make. These are kind of like the major types of columns. You can also do columns that have maps in them, columns that actually have records and structure within them. But these are the basic types that are kind of the most common ones that you might use. So once we've created a table, if you want to see what the schema for the table is, you can do a show create table and then the table name. So we show create table, flight schedule, and then we can see on the right, we see here's our create table, and here's our flight schedule, and here's all of the stuff that we put in about the columns and their types. But what's all this other stuff? If you look underneath the bottom, this is just default information or default settings that Hive adds for you. So SERDI is just the serialization, deserialization. So that's just really the data format that Hive is using to store the table. And this table is a default table. By default, tables get stored in a ORC format, which is what we call a columnar format. And that is the fastest, best format for Hive. It's going to give you the fastest queries and the most compressed data. So we'll see the row format and the input format, the output format. They're all ORC, and the location of where it's actually storing the data. So if I went to this, we can see this is stored in S3. The tables can also be stored in HDFS as well. So, and then you'll see some stuff down here, bucketing version, transactional equals true. So by default, tables are created, they're transactional. And we'll talk about what that means. Transactional basically just means that you can insert and update the tables, as opposed to an external table, which is just is not going to be able to be changed. It's just going to be a append-only table. Okay, so we created a database, we created a table. Now we're going to insert some data into the table. So we're going to insert a row, and we're going to insert one of those flights into the table. So we're going to do an insert into table, and then we're going to tell it the table name, and we're going to put in the values. Now, these are just values, right? How did I figure out where, what order to put them in? So they have to be, so these columns have to be the same order as the order of the columns that they're defined in the table schema. So you notice that we gave it, the airline name, the flight ID, the aircraft type, et cetera, et cetera. So these had to match the table schema. So that's why that show create table is a super important command, because you have to do stuff like this, and they have to get them in the right order. If you're using a tool like like Spark, or you're using something like JDBC interface, it'll take care of the order for you. But if you're going to do the SQL like this, then you can then you have to have them in order. So we created a database, we created a table, we put some data in it. Now we want to be able to read it back. So the simplest of all queries is the select star from table. And we recall that these are big data tables that have lots of data in them, right? Like billions of rows of data. So when you're selecting when you select star from flight schedule, and you don't tell it anything else, it's going to go out and show every single row in the table, which is going to be overwhelming. So typically, if you want to see what's going on, you're going to give it a limit command. You're going to say select star from flight schedule, limit, and then however many rows you want to see. So I selected 5. Okay, so and then the results look like this. So here's each one of the columns, and here's the data from the column. And so this is probably the simplest of all of the queries. If I don't want all of the data, if I don't want all of the columns, then I can tell Hive which columns I want. So I can say select, and then I can give it the list of columns, and I tell it the table. So select, comma separated list of columns from the table name. And again, I'm giving it a limit 5. And that is going to give me just the columns that I asked for. So you might be asking yourself right now, why would I just want to ask for specific columns? Like, why not just get the whole thing, right? Well, okay, I'm going to return you back to the idea that we have big data, right? So big data means that in order to improve our querying time, we want to cut down on the amount of data that we have to get, that we have to pull through the system, that we have to bring back to the client, right? So the less data you ask for, the more fast your queries are going to go. So you can cut down on the amount of data by cutting down on the columns that you're asking for, and you can also cut down on the rows too. So you can do that with a where clause. So I showed you creating a table and then doing inserts to put data into it. But Hive can also do some other interesting things with files, right? So this is a file that I got from Kaggle.com. Kaggle.com is a data science, it's like a data science competition site. If you're looking for data, they have a lot of data there because they have data from all these people put it in, and they also have it from different competitions. So I just went to Kaggle, poked around and found this file. It's the flight route database, and it is a comma separated value file. So it's basically just a list of values that are separated by commas, and it's kind of like a table, but it's in CSV format. So Hive is actually pretty smart about where it gets its data from. So we created that transactional table, but we can also create an external table where we basically just tell Hive, here's a directory that has files in it, and I want to be able to query those files. So I just create table, very similar, except I say create external table. I give it the table name that I want it to have, and then I give it the names and types of each one of the columns in the CSV file. So this one had airline ID, source airport, et cetera, et cetera. If we go back, that's what this, you can see here. Here's the CSV file. And I told it that it's a comma delimited. It's a row format that's comma delimited. So you can have different, you have different kinds of terminators for the fields. And then I told it it's stored as a text file. So this is basically just all these words here, the row format, delimited fields, terminated by comma, stored as text file, is just telling Hive it's a CSV file and it's in textual format. And then I tell it the location. So I put this into S3, and my Hive is going to go out and pick it up. And now I can query it. So for example, here's a different kind of query. So for example, if I want to select both the airport source and the number of times that airport source appears in the table, I want to count those up. And then I want to group by the source airport. So basically, and then I'm ordering, descending. So basically what I'm trying to find here is the airport with the most outgoing flights. And so this is an aggregation query. So we've got a group by and we've got an order by. So, and there are lots of complicated queries that you can do. Okay, so I've gone through the basics here. The next steps are to learn about how do I get data into Hive. So this is a whole topic in and of itself. There are many different ways that you can get data in. You can use a data movement tool like NiFi, which can actually do inserts into the database. You can use a streaming tool like Flink. You can use Spark to ingest the tables. You can dump the tables in textual format, dump the files into textual format. This is what we call a landing zone, and then create external tables on them. So there are many different ways to get data in, but it's a pretty big, wide area to learn about. There's also performance. So I touched a little bit on how to make queries perform well. Probably the biggest thing that you can do is store your data in ORC format. So it's great to be able to ingest any type of format, CSV, JSON, et cetera, XML, et cetera, right? But the query engine isn't that performant when you have those formats. You're really, and it's very simple to take those formats and then do a query that will insert them into an ORC table, and then all of your queries will go faster. So that is performance. Security, again, you want to make sure that all of your data is secure, that only the people that should have access to the data have access to the data, and that the data is properly redacted as necessary. So for example, when you're showing a credit card number, you show the last 4 digits. Or if you're showing a social security number, you're just showing the last 4 digits. And then there's also a topic about learning about ACID and transactions. So what we've shown you here is inserting data into Hive and querying it back, but there's also being able to update it and delete it. I have some resources here. Maybe one of the folks on the on the back end here can help tweet out some of these resources. But I'm going to stop here, take some questions, and then maybe we'll do a little demo.
Hey, I'm back. That was awesome.
Hey, he's back. He's back.
So we do have some questions, it looks like, but from my understanding, we have people answering some questions in some of the chats too. So
Awesome.
apparently Bill Zhang is creeping in the back, man. So for those that don't know, Bill is actually the Hive PM, so he's in charge of Hive.
All right, now. So this is good. This is good.
So we're going to go through these questions. We got about 7 questions, but Bill, correct us if we're wrong. Trust me, you can always hit us up on Slack. But yeah, so the first one is from Ashwin Ashok. So, and coming from YouTube, and the question says, so is it correct to say that Hive queries execute MapReduce underneath it?
That is an excellent question. So it used to be the case that Hive ran on top of MapReduce. So remember Hive was developed by Facebook, and there was only MapReduce, and that was all we had. So it's kind of like, in the beginning, there was MapReduce, but now we have lots of other stuff. So MapReduce is really great for doing big, long queries, right? Like I want to do some like monthly query, and it's going to take me a really long time to do it. But it's not so great if you want to do things that are fast. So in the beginning, being able to query something, a lot of data and not have to get it wasn't a big deal, right? So nowadays, people are impatient. They want to be able to query their data quickly and get an answer back quickly. So we have lots of other tools that we use. So some queries will run on top of the TES engine, which is an optimized engine that's similar to MapReduce, but faster and more nimble. There are lots of things that go on behind the scenes to make the queries fast. So we also have Hive LLAP, which is basically it's a memory-based system. It's like a caching mechanism, and it does smart fast IO, and when it runs on top of the database, the data warehouse, it actually runs on top of Kubernetes and it auto scales, which is totally blows my mind. But it's really awesome stuff. So yes, Hive can run on MapReduce, but that is not necessarily the way most people would run it today. Most people would run it on top of TES, or they'd run it on top of LLAP or Kubernetes or something like that.
Or Spark.
But yeah, that's a great question.
Spark was an engine. And just to add, right, so what, like, for those out there, because this is a 101, what is MapReduce, right? So you have essentially mappers, right, which actually take and filter the data, right? They organize the data in such a way so that you can grab it in a sorted order. And then you have the reducers, right? They actually grab the summary of the operations and put them together for you. So when you're running, Carolyn talked about this thing called Beeline, right? So back in the day, right, when you'd go in through Hive CLI, you'd actually see these mappers and these reducers actually come up on your screen. So you could see how many mappers and reducers, and you map those to a container in Yarn. So, well, it's awesome that you talked about LLAP. So I'm going to skip ahead to that question because someone asked a specific question that I feel like you're going to know the answer to. And it says, does Hive have, and this is, I'm sorry, D Davis 0226 coming to us from YouTube, does Hive have an in-memory component, or does it issue queries directly to the storage each time?
I think we have some closet experts on this. These are not one-on-one questions, but I'm glad you asked that. So Hive does have an in-memory component. It has a couple of different accelerators. One is, I've already talked about, is the LLAP, and that is a smart cache. It caches data. So if you're doing the same queries over and over again, the caches are pre-populated and your queries go fast. We also have what's called a materialized view. So if you want to accelerate queries, like if you're doing aggregations, if you're doing, the types of queries that you want to do fast, but they might take some time if you did them over and over again. You can have the materialized view, which will kind of keep the query results around so that you don't have to keep doing all this aggregation over and over again. And the third component we have is what's called the query cache. So the query cache is, I did this query. So let's say you have a dashboard, right? You get a dashboard that's out there and it's showing the same data and multiple people are opening it. Instead of doing that same query over and over and over again, it's going to cache the results and somebody asks for the query and it's like, boop, there's the results. And so those are just a couple of different optimizations that are out there. But Hive is like a hugely optimized product, and there's lots of different things that you can do to make your queries fast.
Yeah, it's same person. So D Davis 0226 coming from YouTube says, can you run Hive if your data is stored in Azure Data Lake Storage Gen 2? So ADLS Gen 2.
Mm-hmm. Yeah. So Hive can read data in multiple formats. So it can read data out of HDFS, it can read data out of S3, it can also read data out of ADLS, and also Google Cloud Storage as well. So, and Ozone, right? And probably at some point, the Iceberg thing?
Iceberg.
Yeah. I don't really know much about Iceberg, but it has a cool name, and I like it. So, yeah.
All right. We also have Teaching the Machine coming from YouTube.
Hey, so, how's it going?
Does Hive have to be RDBMS, or can it run on a NoSQL engine?
Does it have to be RDBMS, or does it run on NoSQL? C, none of the above. So I guess at one point they would have called Hive a NoSQL engine because it didn't really have SQL, but now it has SQL. It has ANSI SQL. So,
right.
Yeah, NoSQL was kind of a fad for a while until everybody decided that they really did want to have SQL after all.
Yeah. And I think something to add to that, right? So if you think of it the way that it, an RDBMS, you have essentially things, essentially there's different types of schema, right? You get a third normal form. We could get into all the RDBMS stuff, right? But, Hive is running off a file system, right? It's a file system, storage underneath, and now object storage underneath. There is something like HBase, which, most people could throw into that NoSQL realm. And although Hive does have a storage handler where you could put the data in HBase and run some stuff on, it's not as performant. And matter of fact, because of that, HBase has its own SQL execution engine, right, where it's now got Phoenix on top of it. So, just
even HBase has got SQL now.
Yeah, pretty much. We have Manoj Kumar. So are these queries database platform dependent? And he's coming from LinkedIn.
That's a great question. So in the beginning, Hive had what they called HQL, which was a pretty specific Hive flavor of SQL. But now most of the queries are ANSI compliant. And so, if you look at, so there's a database benchmarking standard, TCP/DS, right? So it's a database benchmarking standard. And one of the things that you look for when you do the database standard is how many of the queries can you actually do. And I think we can do all of them, if not a very huge, like maybe there's one or two that don't run. But for the most part, it's an ANSI compliant SQL.
And we also have Manoj Kumar again, coming from LinkedIn, says, how can you query from different data sources like XML or CSV when the data resides in files rather than a database?
So Hive can read from multiple formats, right? So you can just give it a directory, you can have the files in there, and then you can tell Hive what the format of the files are. So is it XML, or is it CSV, or it's JSON? It can do all of those. And when you create the table, you tell it what the format of the data is, what the schema is of the columns, and then you tell it the location. So you just have to tell it through the URI when you point the table at the file system.
And also, one thing to add as well is surdays, right? So for those that don't know what a surday is, a serializer, deserializer. So, it does have, like, you take JSON content, right? You can actually have a JSON surday for Hive, and you put that as part of the table definition as well. We have, I'm going to butcher your last name at least, so I do apologize. Ezekiel, I'm going to say it's Rochau or Rochakes, coming from LinkedIn, and he wants to know what's the difference about the complete intelligence difference with Azure and cost X example. I assume, like, what's the difference between running Hive in the cloud, on Cloudera versus Azure in the cloud? I mean, is that, I'm assuming that's the question, so maybe that's the question that we'll answer, and if not, then you could follow up with another question. We'll see it come through.
Wow, I'm gonna have to consult legal on this one. Yeah, so running the I said you could run different engines, right, with Hive in different packagings of Hive. And so there are a lot of different things that Hive can do to optimize costs in the cloud. So one thing is it can run on top of cloud storage, which is much cheaper than running on top of spinning disks that you're renting in the cloud, because that is obscenely expensive. So, and the other thing that happens in the data warehouse is you can run it auto-scaling on a Kubernetes cluster. So Kubernetes is a resource management, and it will basically expand its cluster or contract its cluster depending on who's querying the data warehouse. So those types of deployments can help you save money, because you're basically just using because everything in the cloud is consumption based. So you're only paying for what you're using. So you're not just like having instances in the cloud. You don't want instances that are just running and nobody's doing anything with them. You want everything that's running in the cloud to be like fully utilized, and then when you need more, you add it. So that's kind of the way that Hive will help optimize costs. We did just have a benchmark that was completed that compared the costs and performance of Hive queries in the data warehouse against other technologies, and Hive came out pretty well, not surprisingly. If you look at the database rankings, it's pretty highly ranked for performance on the database rankings. So I hope I answered your question. I didn't get myself into any legal trouble.
No, you did a great job, I think. I mean, you didn't say anything one way or the other, but at the same time said, hey, look, we do have a comparison. If you want to reach out later, we can probably give it to you. Last question for now before the demo, and then maybe more questions will pop in. So this comes from Nicholas Moreau, and he is asking on YouTube, can we partition tables in Hive?
Absolutely. And you should partition your tables in Hive. Wow, these are like great questions. I'm really impressed with you guys. These are like much more extensive than I thought people were going to ask. But anyways, yeah. So you should partition your tables in Hive because, again, big data, lots of data. We want to only want to cut down on what we're reading for each query. So when you put in a partition, that is going to basically cut down on the data that you need to read when you're doing a query. So when you're doing your query, you put in the where clause, the partition columns, and then that will basically, make it so that Hive only has to read that one partition instead of 2 petabytes of data. So yes, partition your data. And you can usually do it do it based on the structure, the structure of your data and how you're going to query it. So, for example, for cybersecurity data, we like to query data according to the day and the hour, right? So a lot of times we just want to know what happened at this time, with this device. So we typically tend to partition on the day and the hour. Other people might want to partition other ways. So like if you're always querying on devices, you might want to partition by device or partition by customer. But sometimes that can kind of, you want to make sure that when you're partitioning, you're picking things that are going to be relatively equal sizes, right? You don't want some things to be in like little tiny partitions and other things to be in giant partitions. So it's a little bit of a tricky business, but yes, you should partition your data.
And I'll add, so there's a great story of someone was partitioning their data by minute, and so they didn't understand as they're getting data in.
Yeah, you don't want to partition by minute.
You end up with these
You'll be
tiny
very sad.
files, and the small file problem is another issue. We have 2 more questions. It looks like that just came in. Carolyn, do you want to take them now, or you want to wait until the end of the demo? I mean,
let's go ahead. Let's do it now.
Okay. We have again, it's Ashwin Ashok from YouTube, and sorry if this is a basic question. So I'm just going to say right now, don't apologize for.
Yeah, no, there's no basic questions. Ask away.
That's why we're here, right? So he says, I'm trying to understand if Hive does something while inserting huge data, which gives huge performance edge over a normal RDBMS. He's trying to understand the distributed nature of processing stuff like in the back end. So how is it that Hive gives you that performance edge over an RDBMS?
That's a great question. Hive is a horizontally scalable product, right? So the more nodes, the more processing and compute you add to it, the faster it will go. So that's how, that's it, at a very high level how it scales. So if you're using LLAP, if you add more LLAP memory, your queries are going to go faster because you're going to have more you're going to have more caching. If you have, if you're using something like Hive on Tez, then you have, yarn containers, and the more yarn containers you have, the more queries, more queries you can do, and the more throughput you're going to have. So it really boils down to the basically having a horizontally scalable product that I add more compute and more storage, and it goes faster and does more queries.
All right, and this is from, and I apologize if I say it wrong. So, Tiramalteja from YouTube saying, why can't we use select star query in Hive? Why doesn't it run MapReduce?
You can run select star query in Hive. It's just that most Hive tables tend to be pretty big. So you want to just put a limit on it so that you're not going to get a billion rows. Right? So
yeah,
it's just, you can do select star and you can tell it without a limit. So if you have a small table, then you can just go ahead and do that. If you don't know the size of the table or it's a big table, then give it a limit. You'll be happier that way.
And
your query will go fast.
And the why doesn't it run MapReduce, right? So I think Carolyn kind of described it with Tez, the execution engine in the back end. But yeah, you want to go through that again real quick, just in case she missed it.
Sure. You can run Hive on MapReduce. It's just kind of slow. So Tez is faster. And I forget I don't know, maybe John knows, but running Hive on Tez is like, I don't know how much. Yeah, it's a lot faster. And running Hive on LLAP will query sub-second queries. So there's nothing to say you can't run Hive on MapReduce. And if you have big, long queries and you don't care about how long it takes to do them, go ahead and use MapReduce. It still will work.
All right, one more, and then I swear we'll get to a demo. This is from Manoj Kumar coming from LinkedIn, and he's asking, can we build multi-dimensional cubes for report generation? And if yes, what's the limit? I like this question.
I'm going to let you answer that question.
So the reason why Carolyn said this is something that I did at a former employer. On Hive itself, what we ended up doing is for a multi-dimensional cube, we would utilize Druid. So we would store the data in Druid as a backend, and Druid, although a time series database, does have cubed architecture, and then we would actually have the Hive on top of Druid. So you can create a materialized view in Hive using Druid as a backend data store. And when you do that, you essentially get a multi-dimensional cube for report generation, exactly like you're asking. So you can do it. Hive by itself on HDFS cannot. But if you use a backend, something that actually has cube architecture for the storage of the data, then yeah, look at Druid. Druid's pretty cool.
Yeah, Druid's cool. We'll do that in a future meetup. That's also another big cyber thing. Druid is like hugely useful for things like anomaly detection and those sorts of slicing and dicing queries that you want to be able to do. So it's good stuff.
Yeah. All right. All right. Last one. So this is Ezekiel again from LinkedIn. And where are the DC for Latin America? Because X example Azure or AWS, the latency is very high, corporate with other solutions. I'm not sure if you're asking like where's the data centers in Latin America, because that's something that's well outside of our scope, although we do have colleagues in Latin America, depending on where you're at. One of my good friends, Thiago, is down in Brazil. But because X example Azure, AWS, the latency, I think that's more of a cloud question than a us question.
Yeah. So again, when you're querying data in the cloud, you're going to query data that's in your same region. So it's the locality of the data is important. So you don't want to have your data stored in, on one side of the globe and your processing and compute power on the other side. So, and that goes for if you have any deployment, right? Like if you're in your own data center, if you're in the cloud. So typically when you deploy your compute and your storage, you want to have them close by each other so that you have good networking in between.
Yeah. All right.
Otherwise your queries will be really slow and you'll be very unhappy.
Yeah, and you're going to pay all that.
How do I know this? Because I did it by mistake once. I'm like, I'm querying this S3 bucket and like across the globe. So yeah.
And your network cost will go way up.
Yeah, don't try this at home.
All right, that's it for now. Keep the questions coming. Like we said, we'll break back and see if there's any more questions before we do the raffle. Right? You want to get those questions in so that you get a chance. But Carolyn, you want to give a little bit of a demo?
Yeah. So let's talk about this. So I gotta share again. Okay, so here we have data warehouses. I'm just showing you this because we have a data warehouse. Remember I was saying it scales up and scales down. Here's our Hive data warehouse. It scales up and scales down. So that's interesting. I'm opening up the, this is the Data Analytics Studio. There's also another tool that's a GUI tool, which is called Hue. I don't know, we can try and open that one up. I'll show you what that looks like. Looks pretty similar, right? So the first thing you do when you get onto any database system like Hive or
Hey. So I got to interrupt you for 1 second. You're not sharing your screen. You got to share your screen. No.
Oh my God. Like I said, anything could happen.
My imagination, though, I was with you the whole way. So, but go ahead. Sorry.
All right, here we go. Back to the future here. So here's our data warehouses. They're scaling up and scaling down. You can see I just did a few queries to warm this guy up, and he's you can see here he's scaled up. I have two different editors that I can show here. One is the Data Analytics Studio, and the other is Hue. They're both they're very similar. You type in a query, you press a button, and the query executes. So it's just they have a little bit different interface. Hue does a lot more things besides just Hive. So the first thing you do when you get onto a system like Hive is you want to see like what tables do I have and what databases do I have. So the first thing I can do is show databases. I'm going to do that. And I want to see what are my databases that I have in here. So it's going to query. I have cyber, I have flight, I have football test. I don't know what this is. But anyways, let's go in here. We're going to pick one of these. We'll pick our flight database. And then we want to see, once we get into the database, then we want to say, what are my tables? So I'm going to show tables. And you can see I have two tables that I created here. One is the flight route. I wonder if this is, thinking maybe this, I don't know if I can make this any bigger. Let's see. That is not good. Okay, so we have showing the tables, flight route, flight schedule. So that's nice. Let's go in and we'll see what the schema is for the table. So here's, we're going to show create table. And, some of these tools are kind of nice. Like you can see the Data Analytics Studio and Hue will do this as well. It has autocomplete. So if I don't remember, the table name exactly, I can do this, and then I'm going to tell it to execute, and we're going to go look and see, okay, here's the create table for flight schedule. This is the example that I showed you before. The columns are here, and then this is all the other stuff that Hive put in for me about the default table setup. So let's go ahead and we're going to select star. Let's see what's in this table. Select star from flight schedule. And I'm going to give it a limit. I only have one row in this table, so I know, but here's my row, airline, flight ID. Here's all the data for that row. If I want to see my other table, which is a little more interesting, let's do show create table. This is my external table that I created from the Kaggle file. Show create table route. We can see here it's got things like the airline ID, source airport, destination airport, etc. Code sharing. So let's again look at this table. Select star from flight route, and let's give it a limit. Let's get a few more. We'll pick 10 rows because we know this one's a little bit bigger table. We're gonna go off. We're gonna query this guy, and we can see all of the flights that I have here. And so let's take we didn't go delve too much about this in the we didn't delve too much into this during the talk, but let's say we want to say what are all the flights that go to let's say SFO. So we'll say select star. Oh, we're on the East Coast, so we'll do Boston. Select star from flight route. And then we're going to say where. And then this is being really nice and telling me all of the different things. So let's say source airport equals, and then let's say Boston. So here we can see all of the flights here with their source airport of Boston. And let's say we don't want to see all the details of this. We just want to say, I just want to see, how many there are. So I'm going to say select count star. This one's going to take a little bit longer. So there's 212 flights that are originating in Boston. All right, so let's take a look at, so this is, kind of your basic power user interface. We can query data here. We can also go and we can look at this data in more of a visualization interface. I'm actually going to go over to a different system here. Where's my data warehouse? Here we are. So let's say I want to look at some visualizations. I can open a visualization tool and I can put these queries onto a dashboard, right? Like I don't want to just see the text. I want to see something that makes a picture that helps me understand what's in the data. I can just go in here. I can put them on a data visualization. I don't know. This is like bubble charts and different. But these are all again driven by. All of these visuals are driven by the data inside the data warehouse. So, we have the access, which is from just the, here's the select star where queries, and then I can do this and create these visualizations and not have to know anything about the data. And you can use, this Cloudera data viz or Tableau, or there's a whole bunch of tools that are like this that you can use. Okay, so as far as a demo, I think that's pretty much it. I'll take a few more questions if there's any more questions, or if someone wants to just ask something so they can enter themselves in the drawing. Not that anyone here would do that.
Any more questions coming in?
There he is.
Hey, I'm back.
I can see you talking, but
well, sometimes I just talk to myself. So I don't see any new questions, although it looks like someone's put one in now. I have a question, right? So I noticed that count star ran a little long. Did you end up computing statistics on that table at all, or no?
No, I didn't. I didn't do anything with that table. But computing statistics would help a lot. And also, typically when you get something that's in like a CSV format or JSON, you want to be able to just query that out. And then basically you do a select, and you select everything in the table, and then you insert it into another table that's just like it, but it's in ORC format. And then your queries will go literally like 100 times faster.
Yeah. That's what I was just
saying. One line of SQL makes everything go 100 times faster.
I saw that and I was like, oh, I wonder if she computed statistics. And it stores a lot of those statistics, right? It stores the count statistics in the metadata, right, as part of the components of some of those statistics. So doing a count star then after you compute statistics, it's basically like an instantaneous response. Oh, we do actually have a new question now. So this is from Drew Nicolette, coming in from YouTube. So coming into the demo later here, sorry if you mentioned this already, but what's the difference between normal SQL and HiveQL?
guess it depends on what you mean by normal SQL.
I would assume ANSI.
I mean, ANSI SQL, so Hive is ANSI compliant with its SQL. It didn't used to be, but it is now. But there, even like Oracle and all the other RDBMS vendors are sort of not compliant either. But yeah, it's ANSI SQL. Oh, okay. Here comes Kitty.
Oh, I hear.
I was disappointed she didn't come at all. I don't know if you guys heard the meow. She's pretty loud. Anyways.
Yeah, so if you guys have any more questions, please we'll give it another minute or so and see if something comes in. It could be very, very simple questions, right? It doesn't really make a difference.
I don't know, but I see that we have a special guest backstage.
I know.
A special surprise guest. It's Bill Zhang. Hi.
Bill, what's up? You got to say hi to everyone. You're on camera now, buddy. You're on mute.
Like I said, anything can happen.
No, Bill, if you look at the screen, you can actually, you have to go to your thing to go ahead and unmute yourself. It's his platform. It's brand new. But anyway, this is who Bill is. We just want to show you. He's over actually here. So let me move a little bit. somewhere past Carolyn. So Bill was the person that was answering some of the questions on social media. Bill is PM. So for those that don't know what that is, right? He's actually the program manager. So, if you think about it, you have a bunch of, it's an open source project, but we have a bunch of engineers that work on these open source projects, right? So they commit code back to the open source, what they call an upstream release. And so what Bill does is he actually takes all of the work that has to come in. So we take, requirements from customers, things that they want to see, any of this stuff, and actually prioritizes these things, right? So you actually end up with these, a thing called a JIRA, right? Everyone, if you guys are familiar with, basically committing code, you do it through JIRA. Essentially Bill then prioritizes all of that stuff to see what can go, what our engineers can start to work on, what new things customers need to look at. So all of that, comes in, and Bill basically prioritizes that. He also works on a lot of what's going to happen in the future. So Carolyn talked about Iceberg. If you guys don't know what it is, it's really cool. It's got this thing called time travel. I know we're getting a little too much, right? But it's got this thing called time travel. So any snapshot in time, you can go back and look at the way that data was and compare it to the way the data is today. So, it does look like Bill's having some audio issues.
Mind-blowing.
Yeah. Well, it looks like Bill's having some audio issues, but that's what you get when you go live, right? And so
anything can happen.
So what we'll do is this. I'm gonna click over to the presentation. We'll see if we can get Bill's audio issues fixed in the back end. If we can, we'll come back so that Bill can kind of end it and give a little bit of a hello and who he is and what he does. But we're going to go into show what the next meetup is, and then we're actually then going to go from there and do the drawing, right? So I'm going to.
All right, because we're going to give out the swag.
I'm going to share my screen.
This is the best part.
So if you see here, right? So we wanted to say this is when the next meetup is. The next meetup is coming to you guys Thursday, February 25th. Apache, NiFi, and Kafka collect data in the cloud. So for those that don't know me, I am a huge fan of Apache NiFi. So I love NiFi. Don't miss this event. Let me see. Does anyone know? Is this Tim Spann running this? I know this is in Virginia. Ooh, okay. So if this is the Virginia meetup, that would be pretty cool. No, it's not. Is it the Princeton one? If it's the Princeton one, that would be fantastic because that means I most likely will be there. I usually go where Tim Spann goes. It's a known fact. And now we're actually going to do the drawing. So I'm going to refresh this. And it looks like all of the names are in here, you'll see. So what I'm going to do is I'm going to add the names. All right, so the first prize winner goes to Ulysses Rangel. So Ulysses, hold on a second, because I do have a slide to tell you what you're going to do, right? You're going to actually have to send an email with your name and the platform that you existed on. So I do have a slide coming up to show, but I want to get the second winner. And the second, hey, Drew, just in the nick of time. So Drew comes in, asks the question, bam, wins the second place prize. So we have Ulysses and Drew. And for Ulysses and Drew, what I need you to do is you need to email socialmedia@cloudera.com, right? And then essentially your name and the platform that you watched on. This way we can match everything up. So that's pretty much it for those. Were we able to fix Bill's camera? Or I mean, his mute. Bill, if you go down to the mute button, you'll see the mute on the screen. Hit the drop down and make sure it's connected to the right device. That might be why you're not getting the microphone. It'll give you the list of the microphone and the speaker. It has a tendency to default to the home base when you're using a headset. We'll see if Bill can figure that out. If not, then let me stop sharing. So congratulations to our prize winners. All three of us are back. Bill, can we hear you or no? No, it doesn't look like it. No. But we know Bill is with us in spirit. Bill is definitely with us in spirit. Of course, Carolyn, awesome job today. I actually learned a little bit more too, right? So that's the cool thing about these, is that you get a little bit more depth of knowledge. So, anything that you want to leave everyone before we leave?
I just want to say a huge thank you to you, John, my partner in crime. And to everybody who's behind the scenes that helps this meetup flow. We've got Tui and Bill, and they're sweating it out behind the background, making sure that that everything happens well. So
and Shelby, we forgot about Shelby earlier.
And Shelby, Shelby is totally a force to be reckoned with in the social media area. She's like our social media. I don't know. Just huge hero. So anyways, thank you so much for joining us tonight. I'm really excited that you were all here. Tell your friends and let me know what you want to do for the next ones. I'm thinking we'll probably do something with either NiFi or Impala. So awesome having everybody. Yeah.
If we do the NiFi one, I have no problem doing that one. So that's
all right. So John's signing himself up for NiFi, and I've got one of my colleagues in the Marty Lurie, who's going to do some Impala. I'll probably make a second appearance and talk about Flink, because I'm deeply into Flink lately, and it's really, really cool stuff. So anyways, thanks so much for being here. Have a great night or day wherever you're at, and look forward to seeing you next time.
All right, awesome.